fill in the blanks. The answer will be given to you in a shuffled order. You only have to select those correct answers and answer the questions given below. What are the mechanical properties of it? How it can be varied, how it can affect various things around us, and how we can actually manipulate and study and understand them. A set of questions will be given to you as MCQ questions, where you can actually pick the right answer from the options given, and you will be awarded 1 mark for each question. Hey all! I'm Hari Krishnan from the Department of Physics, Vidyasram PU College, the Temple of Excellence, Mysore. We'll be taking a look at all the chapters you will be dealing with this year, what are all the concepts, which are all the areas you will be in touch with, and how you should actually answer questions, how the question paper pattern will be set, and what all experiments you have to do in this year related to physics. So without further ado, let's dive into it. These are the chapters you'll be taking a look at this year based on the NCERT norms. So you'll start with units and measurements. The first chapter is very important because without units or proper measurements, we cannot lead a civilized life or we cannot make any scientific breakthroughs. For example, we can say that the distance from Mysuru to Bangalore is about 10 songs. But that is not a standardized unit of measurement. So that is why we have introduced units and measurements, which will clearly explain what are the accepted units and what are the accepted terms and symbols for measurements. Coming down, once we know how to exactly measure things, then we can start moving. After studying about units and how to measure things precisely, we will move on to motion in a straight line and motion in a plane. These are the chapters which deals with the kinematics of objects, how objects actually move, or simply how motion takes place. And once you study that in depth, then we'll move on to laws of motion. The laws of motion deals with how general objects move around, how they interact with the nature around us, and what are the laws they would follow. And the laws of motion include the famous 3 laws included by Isaac Newton. Laws of motion, which is the first law, second law, and third law, which we will be studying, including derivations. So, then moving on to work, energy, and power. How work, energy, and power are interrelated and how they can be used in a scientific way to make sense to everyone around us. And after that, we'll be dealing with system of particles and rotational motion. In this chapter, we'll be studying about a system of particles and motion not in a straight line or a plane, but rather in a circular pattern or when it executes a maneuvering pattern. And finally, we'll be studying about gravitation. What exactly is gravity? What are the laws associated with gravity? And the famous question Isaac Newton asked when he discovered the effects of gravity. When an apple fell, he observed that and he asked the question, if an apple can fall, can the moon fall into the earth? And that question led to all the equations and theories of which you will most likely study. It's a chapter having a lot of fun and a lot of experiments along the way, and we can have practical examples and we can understand the world around us and how such a weak force can influence our lives so much. And these are the marks distributed for each chapter. And these are the number of hours allotted by the board for the completion of each chapter. If you look at the extreme end, you can see that it is the estimated time of completion. So we'll be completing each chapter before the board allotted time in an efficient and precise manner. So moving on, your chapters are not finished, you have still more chapters. And here we'll be dealing with mechanics of solids, fluids, and thermal properties of matter, thermodynamics, kinetic theory of gases, oscillation, and waves. So at first we'll study how objects actually in a straight line, in a plane, and later we will study what happens when they move around in a circular pattern or rotational motion. And after that we'll study the effects of gravity on them, how matter interacts with other matter around its surroundings. And then we'll come down to mechanical properties of solids and fluids. What exactly is a solid? What is a fluid? How the fluid reacts to everything around it? What are the mechanical properties of it? How it can be varied? How it can affect various things around us? And how we can actually manipulate and study and understand them. All this will be discussed in these chapters. And finally, when we are coming down to thermal properties and thermodynamics, we'll be dealing with heat. So it won't be the heat you heard all around your life, because heat in thermodynamics just means transfer of energy. So here we'll be dealing with macroscopic properties of matter relating to energy transfer, work, power, and so on, how a system affects each other, and all of that will be studied under these chapters. And finally, coming down to kinetic theory of gases, we'll study about how gases interact with the nature around us. What are the general properties of gases? Are all gases the same? Is there any difference between different kinds of gases surrounding us? And how they are going to interact with us if we provide necessary conditions. If we change those conditions, how will they react? Will they react violently? Will they be okay with any change? All of that will be discussed in these chapters. And finally, oscillation and waves. You might have seen all clocks with pendulums hanging below, just swinging around. So we'll study about that motion, why they are swinging around, and what is it called, what are oscillations, what is its specialities, is it relevant, and does it have any significance in physics? And all this will be studied under oscillations. And finally, we will study about waves. Are waves similar to the waves you see at oceans or like huge seas or in water theme parks? Are all waves similar? Is there height differences? Is there property differences? What exactly is a wave? Is a tidal wave similar to an electromagnetic wave? What is an electromagnetic wave? All these questions will be answered in a fun way so that you can understand the world around you in a scientific, systematic manner. So these are the chapters you will be discussing in this year, and again, these are the marks allotted for each chapter, and right beside that, you have the number of hours allotted by the board to complete each chapter. And finally, we have our estimated time of completion. So we will be finishing each chapter efficiently and precisely before the board allotted time. And moving on, so how do we actually evaluate you? Do we just ask questions in the classroom? No, right? You have to obviously write an exam. So how is your mark distributed throughout? And how the question paper pattern is set? How should you answer the questions? What all questions will be asked? All these are general doubts you might be having. So a clear-cut explanation. So as instructed by the Pre-University Department, Government of Karnataka, we have theory and practicals all together for 100 marks. Out of that, 70 marks will be your theory examination where you can write and score, and the remaining 30 marks will be allotted to you through experiments. You have to practically show them you have understood the theory and you can apply that in a real world application scenario. So that is 70 marks for theory and 30 marks for practical, and you'll be having a grand total of 3 hours and 15 minutes to write the theory examination, so you can write really well with diagrams. Moving on, let us discuss about how your question paper pattern will be set. So to be precise, you will be having 4 parts: part A, part B, part C, and part D. And out of these 4 parts, there will be subsections how the questions will be divided. So you will be having 6 sections, and part A and part D will contain 2 sections each, while part B and part C will contain only 1 section each. And so the manner how part A works is that a set of questions will be given to you as MCQ questions, where you can actually pick the right answer from the options given, and you will be awarded 1 mark for each question. And in the section 2, it will be fill in the blanks. The answer will be given to you in a shuffled order. You only have to select those correct answers and answer the questions given below. And that is part A. And coming down to part B, you will have to answer 5 of the given 9 questions, and you can pick whichever one seems more suitable for you. And then you have part C, same pattern, that is 9 questions will be given to you, out of which you will have to answer 5 questions. And finally, part D will be given 6 questions will be given, out of which you will have to answer 3 questions. And section 6 will be 4 questions given, out of which you will have to answer any 2. So generally, part D contains the questions where you have to draw diagrams, construct circuits, and prove theorems, derivations with equations, examples, all that will be given in the part D part. So you'll be gradually climbing up the questions, where first will be MCQs, then you can pick the answers from the options given, then you'll have to write something in a short manner, then you have to elaborate answers in the next part, and finally you'll have to prove theorems or derivations and construct diagrams or circuits, etc. I know you'll have a confusion while I say that. So that is why I have given a model question paper for you to actually understand what exactly is going on. So first, general instructions will be given. So all parts, that is part A, B, C, D, are all compulsory. You should answer and you have to answer each and every one part. And after that, part A, questions will be given. Since it's an MCQ question, even if you write 2 or 3 answers, only the first answer will be considered for your marks. So make sure you're writing the correct answer and don't leave anything up for luck. And coming down, you should actually draw relevant figures, diagrams, equations, formulas, etc. for you to secure the marks, or you might lose marks. And finally, direct answers to the numerical problems without detailed solutions will not carry any marks, which means that if there is a numerical problem that requires step-by-step solving, you should actually calculate and arrive at the result. Instead, if you write your answer down magically as the result, you won't be given sufficient amount of marks. So that's something you have to be really careful about. And coming down, this is part A, in which questions will be provided and 4 options will be given, out of which you can select whichever option seems more suitable for you. And coming down to part B, and this will be the form the questions will be given, and you can select whichever question you want to write. And finally, for part C, questions will be given. You only have to answer a certain amount of questions, others are options. And similar is the thing for part D. And if you look at here, so derivations and all will be here in part D. So you'll have to allot more time to part D. And this is the most important part of a question paper. And finally, how to summarize all this? Very simple. So you'll have to know the syllabus, understand the concepts, develop your own strategies. It's not like you have a definite pattern to answer. You can answer the way you seem most fit for you, and have knowledge about the question paper pattern, which we just discussed, and relevant diagrams, circuits, which are also important. And finally, problem solving skills, numerical problems, derivations, formulas, everything is very important. So if you follow all this, I think the examination will be fairly simple for you. And finally, the most awaited parts, the practical application of the theory, that is the list of experiments you will be completing in PU first year. So starting off, we have a list of experiments which you will study the theory actually. So if you study a part in your textbook, which is units and measurements, you will have an experiment related to that chapter. For example, vernier calipers, screw gauge, etc. will be measuring devices with particular units. Like that, in all of your theory, you will study various concepts and ideas. So that will be implemented in the real world. So we are just checking that the theory is correct by you proving it on the spot. So basically, we are proving that whatever theory we are going to study, it is innately true. It has real world applications and it holds true. So we are actually proving it with these experiments, and it clearly states that whatever you have studied, you have understood them to a level that you are strong enough to practically implement them in real world. So these experiments will help you in that. And you have a total of 17 experiments. We won't be doing all 17 of them. We'll be doing a select number of experiments which you can manage. So that's it. So we'll have theory and we will have practicals, which together make your education complete and holistic. And if you really try to understand the physics behind everything and acknowledge the fact that we are not proving anything out of thin air, we are just understanding the world around us and giving it a proper explanation, things will be much more simpler for you to understand. So the only thing you need to study physics is a curious mind, that I believe you will have, and we can ask a lot of questions along the way. So I hope you are clear with everything I just said. That's all, and I'll see you again in the next class with more physics. And until that time, thank you very much.